All right, so hi, we are the Golden Gorillas, and our product is DASI, the diagnostic aid for skeletal injuries. So I'm gonna start off. We're gonna introduce the team. My name is Dhruv Chandna, and I worked as the data scientist, ML engineer, and backend developer for the team.
Hello, I am Felix Sohn. I'm the front-end developer and machine learning engineer for this project.
Hi, my name is Lalita Narayanan, and I was the front-end developer and machine learning engineer.
Hi, I'm Sammith Krishna, and I'm the front-end developer and machine learning engineer. I also dabbled in a bit of the data, so yeah.
Hi, I'm Ray Tang. I worked on the front end and I also worked on the data for this project.
Hi, I'm Darell, and I'm also one of the front-end developers and machine learning engineers.
And this is Ryan. He's our amazing instructor. Shout out to Ryan.
So
So
oh,
go ahead.
so when creating with our model, right, we had many ideas in mind, but we wanted to create something that could, actually help the people, contribute to the betterment of health for all. That's why we came up with DASI, the machine learning model used by medical professionals for detecting identification abnormalities in the skeletal, x-rays provided to it. So some goals that we had, whilst we were creating this was in, to help radiologists with their jobs because it's pretty rough for them. It was to speed up x-rays and the whole diagnostic processes, and to just help educators teach and medical students learn by using our product as education aid. So the whole process, how does this even work? DASI takes x-ray images and then classifies them as either fractures or metal rod fractures, also determines if there's even a fracture at all, and then this whole thing would make the process a lot faster for radiologists and determine if there's a skeletal abnormality and what it is. Our model is fairly accurate in the whole classification. It can identify various types of fractures in the bones, and also pretty accurately pinpoint where those fractures are. However, since our model was made within less than 2 weeks, it's not like accurate enough to be used on its own. However, it is good enough to be used alongside certified medical professional.
So the timeline, so for week 1, we collected a bunch of data such as metal rod fractures and just normal bone fractures. And we had found a bunch of data sets online. And after searching and finding a bunch of data sets, we managed to get about 400 images. And then through data augmentation, we tripled our data set to 1,200 images. And Ray is going to explain how we did that process.
Yeah, so I'm going to go into a little more detail about the data collection. To collect our data and to augment it, we use this really cool tool called RoboFlow. So basically, first we have to collect all the data and annotate it. Basically, what annotation is we're drawing bounding boxes right on the fractures on the bones. So Dhruv is going to demonstrate that for us right now. Basically, at first we only had 400 images, so we had to split an equal portion of images to every single person. And as you can see, we are able to draw bounding boxes on the images so that the AI model can be able to use these images to train on. But 400 images isn't a lot to train an AI model on. So because of that, we decided we would augment the data. What data augmentation is, it's basically a way to kind of generate more data when you using like existing data. So what it is you can add a bunch of attributes, which Dhruv is showing right now. You can add flips, rotations, horizontal translations, and most importantly, blur and noise, because some of our x-rays were really bad quality. So this also increases the quality of the data in a sense, because now we have a wider range of data to train our model with. And if you put in good data, you'll get a good AI out. So data is a really important step in it. And I'll pass it back to Lalita.
Yeah, I'd actually like to add, we had actually initially had even less data than this because we were looking on Kaggle for like data and we couldn't find too much. So we used this API, SERP API to web scrape. So we got images directly off the web and then annotated them manually. But yeah.
So now in week 2, as Dhruv and Ray were talking about annotating, we have a bunch of annotated data and we put them in their right classes, so metal rod fracture and fracture. And then we started training it, and we also had to re-annotate our data during week 2 because the training wasn't going as well. So we re-annotated, we kept doing it, and then we did it as much as we can to make it the best model as we could within our 3 weeks. And then in the last week, we did the website development, which is what you're seeing right now. And we used HTML, CSS, and Flask. And we learned about the front end and back end. So this is the front end thing you're seeing. And the back end is all the code and everything else that made the website the way it is.
Yes, so with HTML, CSS, and Bootstrap templates, we are able to make the front end of the website, and with Flask, we were able to punt the model into the back end, which Dhruv will show you later on in the presentation. Up above, we have AI Camp and Dazai, which could send you to the website of AI Camp. And what is Dazai? Results, the timeline, team, and contact will take you to each individual subject. And in our icons for email and Discord, if you click on that, you can send information for us and we could answer any questions you need. Also, disclaimer is that the metal rod fractures aren't actually metal rod fractures. We put that to ease the wording because it's pretty long and it's can be used as a medical device that doctors put on you, but we put it as metal rod fractures, even though it supports the fractures to help people understand what it's made out of and what the shape is.
So what exactly are the results of our model? As you can see from the images, DASI successfully detects metal rod fractures and no fractures in x-rays of hands and arms. Taking a closer look, the left number on the boxes determines the type of fracture, so 0 or 1. And the number on the right is the confidence. For both of the fractures, DASI has a decently high confidence when detecting.
All right, so now I'm going to go ahead and show you a demo of the product. So here I have a couple of images. One is just your, basic hand fracture, which is our model is really accurate with. We see here 2 fractures that the model gets perfectly. And then if I try it again, now see in this image, it's really difficult to see the fracture. Actually, when we first looked at it, we couldn't see it either. But then when we ran it through, we found that there is a fracture right here. So this is where the product would really come in handy when, obviously we have human error. Radiologists might not be able to detect a fracture, and they would be giving a false negative to the patient saying that they don't have a fracture when in fact they do. So that's why this product would be used to identify that fracture, which a normal radiologist wouldn't be able to spot on their own. And that's why it's a diagnostic aid. Now, if we go on to more images, it can also do metal rod fracture and legs, as we see here, along with, it can also do both metal rod fracture and regular fractures at the same time. And then I want to show you some examples of errors in accuracy that we had. One is that sometimes it generates false positive results. For example, in this image, Sammith's mouth here is apparently a fracture. No offense. But yeah, so it's, I mean, this illustrates a really important concept in AI of false positive and false negative, which I'll show you in the next image. But it's saying that there is it detects a fracture, but in reality, there's no fracture, obviously. Let me show you one more image.
Quick question. Why do you think it's detecting a fracture again?
Well, that's because of a lack of data. We
actually had a lot of trouble trying to find good data sets for our model because there really isn't a lot when you search up broken bone data sets. It's a really specific query. So, augmentation helped a little but still the base data set's not that much. So yeah.
So
Yeah,
let me rephrase the question. Why do you think the AI thinks that that's a fracture?
I think that it's probably because of, okay, so when you have most fractures, you have, some kind of bone, and then there's a split, right, at the crack. So it thinks of the lips as a split. But yeah, now I was looking through the images, and I found this is a really interesting image. So so this is a false positive. We don't have any fracture here in the X-ray, obviously, but the model detects that it is. But then another interesting thing is right here, if you look closely, there is actually a fracture. So this is actually a false negative where the model didn't detect it, but there is indeed a fracture. So this is our confusion matrix here. So we see that, okay, yeah. So this is what the model predicted, right? 0 relates to fracture, 1 relates to metal rod fracture, and this is what it actually is. So 62.62, 0.58 for the metal rod fracture.
Quick question.
Yeah.
Is this normalized or unnormalized?
This is normalized.
All right, you guys picked it up. Cool.
But yeah, so we actually had another model. This was the one we trained on the 13th. The one we trained on the 12th actually had the metal rod, the regular fracture percentage to be lower and the metal rod fracture to be higher. But we ended up going with this best PT, which is like the weights of the neural network. We ended up going with this because we tend to see more regular fractures than metal rod fractures. And yeah, why we have some of this inaccuracy, it's because we had 2 classes and 1,500 labeled images. So really, it's way lower than it should be for a professional AI model.
Wait,
Yeah.
how many times did you guys have to train this?
So I believe we trained it about 4 or 5 times with different attributes.
Wow.
Yeah. Yeah, so I think our first training was on the 5th. Yeah. And then
I think we also had to decide on a number of epochs to train it with. So we didn't really want our model to overfit. So I think once we trained it to 150 epochs, which is overfitting, just so we can see like the curve of the graph, so we could accurately decide on a spot to stop training. So I think we stopped at around 60 epochs. Dhruv, is that correct?
Yeah, about 70.
Yeah.
Actually, that's a really interesting thing about YOLO, which stands for you only look once, because that's like the updated version where it only looks at images once to classify. But it's interesting because, we were basically epochs are like how many times you go through the data to train it. But what it is that as you increase the number of epochs, your training error will obviously become lower, but then it starts to overfit. It starts to memorize the data. So then when you actually test it, that error, that loss starts to go back up. So we were worried about finding the perfect number of epochs so that there would be no overfitting and the least amount of loss. But then
what we did was we just ran it a lot. We ran it 150 epochs just to see the graph and where the error is the least. So that way we could accurately know, okay, where should we stop training this model?
Well, actually, that's not what we did. I was talking to Prasanga, and with YOLO, what it does is it applies early stop automatically. So even if you give it 150 epochs as one of the parameters, if it sees that at 60 epochs, it got the best results, then that's the kind of model it uses, which is a really cool feature. But yeah, this is DASI.
So when it was overfitting, it was doing that at the point where even the outliers would be classified. So that's why overfitting is bad. So yeah, that's DASI. Thank you, everyone. Does anyone have any questions?
Yeah, so I sent a picture of a broken hand in the chat.
Yeah, okay.
Do you think you could
Dhruv,
Like,
do you want
do
to
Yeah, let me pull it up.
Dhruv, you have to
So
scroll
while
up
you
a little
guys are
bit.
downloading that image and running that, I'm just curious for all the teams. And I can't see some of your pictures, but by show of hands, can you put up 3 fingers, 2 fingers, or 1 finger? How many times did you had to train the model for your projects if you had to do that type of training? I see 2. I see 2. Someone had 5. Wow. 7. Okay. I've not heard of that one. That's probably a record for me at least. Wow. Okay. So did you just loaded the image just now?
Yeah, let's
Yeah.
like.
So
yeah.
it says it detected 1 fracture with 77% confidence, but it's
Yeah, I
not.
don't think there has
Yeah, we
it
can't
has a
see the
middle
bounding
bounding
box.
What did
So-
you do to your hand?
I was playing football and you know.
Oh wow.
Yeah.
Wow.
That looks
Right.
bad.
Yeah, we had to go through a lot of like bad images, but
Yeah.
yeah. And I also really want to, I know I shouted him out at the beginning, but just want to shout out Ryan again. He's our amazing instructor, and he actually put in a lot of effort to help us through this process. Because like we were staying after class a lot to work on it, and he sacrificed his time to help us with the front end and back end and linking them together. So he also helped us a lot with like explaining the stuff when we didn't understand it. So yeah, thanks a lot, Ryan. You really made this project come to life.
Yeah, I guess Ryan was our Stack Overflow.
No,
So
I'm really
I-
proud of you guys. Yeah.
Round of applause first. Thank you. And
I think Dasha has a
what?
question.
Yeah.
Okay, yeah, sorry, I have a question. How are you planning to 1 second. Okay, sorry about that. How are you guys planning to like fix it in the future and like make it more accurate and stuff, because you have trained it 7 times or 5 times?
So we know that there must be like a lot more data out there, right? So in the future we could probably just find more data and try to retrain it. I think another improvement that we can make is like we could find more ways to augment it, because we only applied some of the augmentation methods. And for each augmentation method, right, there's like an amount that you can augment it. So like say it's like rotation, you can rotate it a certain amount of degrees. So that basically increases the variety of data. Yeah, in the future, if we were to like, I feel like if we were to like redo this project, I feel like we would aim for a lot more data. So
Yeah,
We
also
would
if you
probably
look at
use
the-
assistance of medical professionals. 'Cause I remember, whilst we were making the whole box.
yeah, we had a lot
and
of
everything,
trouble
we
annotating.
struggled a lot in determining whether this was a fracture, whether this is normal or not. So an assistance of a medical professional or two would really help in this case.
Yeah, also if you look at the confusion matrix, we see in the background false negative, false positive. The model gets confused with that pretty often, right? 82 over here. So we need to add more background images that are of healthy, normal bone structures, so that it knows, that this is an image with a fracture and that this is a normal one, so it can be able to differentiate between the two. But